I'm pleased to introduce our next speaker, Athanasios Vlontzos, a research scientist at Spotify and a visiting researcher at Imperial College London. Athanasios will be talking about unlocking business impact with causal system design, a lesson from history. Please welcome Athanasios.
Thank you. Thank you for having me here. I'm going to be, as has been said, I'm going to be taking a slightly different approach. I'm going to actually be taking a philosophical approach to the matter. I'm not going to be talking about some specific thing we did at Spotify. We're not going to be talking about very technical things. We're going to be talking about a slightly different way of thinking. Essentially, the argument here is, and to be honest, it's very suiting for this kind of environment that we're in, the Royal Society, is that we should be looking at things a bit more holistically and not only focusing on the modeling, but overall. A few words about myself, because probably you don't know me. I did my PhD in medical imaging at Imperial College London, and right now I'm a research scientist over at Spotify and a visiting researcher at Imperial College London. My experience actually was not in the causal side of things. I came into the causal side of things later on in my career because before I was actually dealing a lot with medical imaging in GE Healthcare, ML4 and atmospheric physics in a weird combination between SETI and the SETI Institute and NASA. I was the AI lead in a company called Zide Medical for ML of stroke detection, and did my third bit of NLP at Apple. Now, if I were to give you one thing to take away from this presentation, it's the following. A problem is not truly solved until we actually grasp the reason for its existence. This is the key, really, thesis of this presentation, and it's very, very important to have this in mind. Yes, please take the photos before I go into the next slide. Cool. I think everybody here really wants to build systems, both AI systems or business systems, that are robust, safe, and intelligent. We want to make decisions based on these systems and on these kind of processes. Now, I think we all agree that causality is a great tool to do so. However, is causality only in the ML modeling? And I think, as I said before, no, it is everywhere. In order to prove that, actually, I'm going to go back in history. I'm going to go back about 2,500 years. And since I'm Greek, I should mention some Greek philosophers, and specifically Aristotle, the gentleman on the left there. Now, Aristotle, in his writings and his books, he actually talked about four causes: the material, the formal, the efficient, and the final. Now, I don't blame you if you have no idea what these actually mean. I didn't know myself until I picked up philosophy recently again after like many, many years. So let's dive in a bit and try to understand what they are and how they actually relate both to what we do in terms of AI, but also what we do in terms of businesses. First of all, the material. This is maybe the easiest thing we can think about. It really refers to the physical substance of things, or the components that actually make up a thing. So it could be the raw data, the tools that we're using, the resources involved. In order to understand it a bit better, maybe we're going to be diving both in the AI front and in the AI context, and also in the business context. From an AI context, we really are ensuring that we recognize the various critical roles of data. It is imperative that we have good data, and we are actually controlling where we're getting this from and what we do with it. From a business perspective, we really are trying to identify the key resources. What is the key resource in order to be efficient? What is the key resource we need to actually do some product development? So essentially, without the right materials or resources, solving any problem becomes impossible. And we actually look into that in a very nice paper that we wrote with some collaborators, published in IJK in 2021, on how to build a causal diagnostic system for long-term space missions. Very interesting kind of scenario. Very challenging as well. Now, we go to the formal cause, and I think this is the one that most of the audience here is a bit more familiar with, because this is where structural causal models actually come into play. The formal cause of Aristotle really refers to the structure that defines something. So, in reality, the structural causal model. So, in AI, we're trying to incorporate this kind of structural causal models. A lot of speakers have actually spoken about that in order to build robust, trustworthy, and interpretable systems. From the business perspective, we're trying to evaluate and find the true drivers of success, because we don't want to be led astray. Now, really, the takeaway here is that without a well-structured model, both businesses and AI models can be misguided, and we really, really do not want that. We actually touch upon this on a very nice paper we published with Kieran here on the first row and Bernhard over at Imperial College London, published in Nature Machine Intelligence, and where we actually talk about estimating categorical counterfactuals. And we really dive into how we can identify these kind of things and use them in a model. Now, in the same paper, we actually touch upon the next cause of Aristotle, and that is the efficient. To be honest, I really had a hard time trying to translate the Greek, which kind of sounds like the poetic cause, rather than, and I saw that a lot of people are using as the efficient cause, so let's go with that. Here, we really find another element that many of you might be familiar with, and this is the do calculus. Because really the efficient cause, as Aristotle was actually talking about, it refers to the agent or the process that brings something into being. So here, both in AI and business cases, we are actually not caring about understanding only the causes of the situation, but also what we can do. What are the best actions that would lead to reliably to the desired outcome. So this is a lot of the things that the previous speakers were talking about on actual decision making, et cetera, et cetera. It is here. It actually falls under the efficient cause. And as we have seen, both with tools that, for example, causaLens might give, or tools that we built in-house at Spotify, simulating and predicting these effects are key in decision making. Now, finally, the final cause. Now, this is slightly different to everything else because it actually brings in the notion of counterfactuals. When we deploy something, when we have something in production, when we use something in real life, we need to make sure that this thing is aligned. We cannot let it be and just go on with our lives. So the final cause of Aristotle really refers to the purpose or the goal. It looks at for example, the AI system's goals or the company's mission, and really here is where we employ counterfactuals to think and to actually think whether or not it aligns. So the AI system we want to align so it improves the decision making, it reduces bias, maybe enhance the customer satisfaction if we're talking about commerce. In business, we're talking about long-term things, might be profitability, sustainability, or market dominance. And essentially what we're trying to say here is that we need to really ensure that we're moving towards the correct goals and not something superficial. So really, if you think about it, when we choose the metrics that we evaluate any sort of system on, these metrics should actually reflect the final cause, that is the mission that we're trying to solve, rather than something that might be superficial. Now, all this is nice and well. However, Aristotle did live about 2,500 years ago, and you could say that a couple of things have changed since then. So let's go back to modern day. If you think about it, what are we doing here when we're trying to make a decision? We employ critical thinking in order to understand the causal relationships and determine the factors at play. We do risk assessment and management in order to anticipate the potential outcomes and weigh the various risks. And we also have a strategic vision or long-term planning. So we can actually foresee the broader implications of our lives, on our lives based on our decisions. So a company doing a decision not only affects the bottom line, but it affects the entire ecosystem as well. So the more perceptive of you might have already understood that actually is the same thing. We are doing the same thing that Aristotle said 2,500 years ago. The form and the material cause manifest in the critical thinking. The efficient cause manifest in the risk assessment and management, and the final cause manifest in the strategic vision. And if you don't want to go by Aristotle, you can actually go by NASA. In the 1970s, NASA, together with the Department of Defense and various other aerospace industries ever since, did develop the Technology Readiness Levels. I see a lot of smiles in the room. I recognize them because they are very, very important, and they have been used ever since. This specific graph actually is derived from a paper by Lavine and al. Back in 2020, where they adapt the TRLs into machine learning, system design, and system development. And they actually start from the first principle, like the very first kind of TRLs are almost research-like before we actually go into the system development, evaluation, and finally deployment. So this is a brilliant framework that has been used ever since, and to be honest, I strongly recommend everybody to start thinking based on this. And to be honest, this is really the purpose of this talk. Throughout this day, I do invite you, please, to start thinking about all the things that you will be listening to, in a framework of, okay, where in this kind of system design and system process and like solution like they would fit in. Now, all this is very theoretical. Let's apply really what we have learned, because application is what we do here, like in industry. Let's say that we are, this for clarity and also for all intents and purposes, this is completely theoretical. I haven't been contacted by Guy's Hospital, I just was walking by Guy's Hospital when I thought of this example. So let's say Guy's Hospital, which is one of the major London hospitals, is actually down the river from here. They have quite a few issues, and they want to actually accurately forecast demand and predict, for example, the various resources they want. They want to adjust the rota, so the medical supplies they might need. So really, they ask us, as causal AI experts or AI experts in general, to implement an AI-driven solution to do that thing, to actually build a model to forecast demand. Let's see how both these two frameworks that we thought of and also Pearl's kind of ladder of causality come into play. Because the first thing that we do when we actually try to evaluate such a problem is think about the problem. So this is really the foundations. This is the material cause from Aristotle's perspective. We're trying to gather the data and see exactly what happens. We try to gather the data of admission records, seasonality, maybe the medical innovation and the drug availability that we have in the UK. And this really is the material cause. From a TRL perspective, this really is TRLs 1/3, approximately. This is the basic research where we are testing hypotheses. And really from Pearl's perspective and causal perspective, this is where we actually are trying to uncover the correlations. Because it is important, it's imperative that we identify the real cause and effect relationships. Because else, this will essentially mean that we cannot build a good model. If we have the data that does not serve our foundations, it doesn't serve our understanding of the potential causes and effect, then the model that we're going to be building is going to be not that good. The second thing that we're going to be doing is actually the actual design. We're going to be designing, for example, the machine learning system that we are looking at, from data pre-processing all the way to inference. And this is really the former cause. This actually is the various tools and the various factors at play and how they are interconnected. From a TRL perspective, again, we're looking at TRLs 4 all the way to 6. And really, this is where the causal diagrams that we have seen in many presentations do come into play, because these really represent the relationship between the variables, and hence allow us to reason about the structure and make sure that the system accurately reflects the complexities of the task at hand. Third, penultimate, I'm not going to tire you too much more. It is the implementation. We are looking at TRL 7 all the way to 9. This is really where the efficient cause come into play. Because as we saw before from various speakers, we are looking at running simulations and evaluating scenarios in order to actually figure out what would happen. This is where the decision-making really comes into play. The data engineers, the data analysts that do these processes really manifest the efficient cause. They are the efficient cause of this system. From a TRL perspective, we're looking at TRL 7 all the way to 9. And from a Pearl's causality perspective, this is the do calculations. This is the intervention and outcome kind of analysis. So training the AI in simulated real-world data and allowing it to run scenarios of the various actions does help us understand and control the efficient causes and behind the actual demand variation that we might see. Finally, we want to achieve our goal. And this is really the final TRL, TRL 9, where we see whether or not our system, the system that we have built, actually aligns with the stated hospital goals. And we need continuous monitoring and improvement improvement iterations, because this would ensure that we still are doing what we have to do as things change, because the world around us is not static. We always make assumptions like the stationarity of the various processes, the stationarity even of the causal diagrams. These things, unfortunately, do not apply in the real world. And this is where we have to be continuously aligned, for example, for the final cause, the TRL 9, in order to make sure that we are actually tackling what we wanted. And at this point, we have solved inefficient management of the NHS, and we can go back home and celebrate. Now, if I were to say what we learned here today with all these kind of frameworks, is that causality is a framework. It's not a modeling technique, and we should be thinking it as a framework rather than a model. It is brilliant if we can use it to build better models, but it is even better if we actually start thinking as like for every problem and approach it in a causal manner. So really, what we said today is that we explored various business system design frameworks. That we explored some from 2,500 years ago all the way to the 1970s and the defense industry. We learned how they actually relate to causality. And as I said, for the third time, causality is everywhere, not only in the modeling. If you want to learn more about that, we actually did a brilliant podcast with Alex Mollak here. That was a very last addition to the slides. You can check out our Nature paper with Kieran and Bernhard. That was in Nature Machine Intelligence. It was a brilliant paper. It got some coverage from MIT Tech Review, and this is actually how we use counterfactual on Spotify. Kieran's going to be talking about more about that later on after the lunch break. And honestly, if you do not agree with me, if you don't agree with anybody else in the room, take it from Bill Gates. He does agree. Causality is indeed fun. Thank you very much, and please reach out if you have anything to discuss.
Thank you. That is the first presentation, I think, that I've ever seen NASA, Guy's Hospital, and Aristotle all linking together. So well done. That in itself is impressive. Couple of questions, at least. I'll start with this one. Do counterfactuals fit into Aristotle's framework? We kind of talked about that.
It kind of do. Like, this is something I was kind of seriously thinking about when I kind of built this presentation. And I would say they kind of come into both the efficient cause that we are talking about, but also, which is essentially this kind of manifesting of the various situations and processes, but also in the final cause. In the efficient cause, they do because really we do this kind of counterfactual analysis when we bring something into being, but also in the final cause, really they do come in because we need to think about whether or not something aligns with what we have done. So like essentially we do an intervention, see what the outcome is, and we are trying to think, okay, if we hadn't done that intervention or we had done something different, would we still be aligned? And this is, I suppose, a very good link between those two. Again, I'm not a philosopher, so like I'm more of a computer scientist and engineer, but like I do dabble in like philosophy.
Clearly. Brilliant. So this one, using the TRLs, and without naming names, where do you think most companies are in their causal AI journey? And what are the biggest obstacles are there to getting to TRL 9?
Honestly, I think a lot of companies vary across all the TRLs. And to be honest, for every single project somebody would run, they would go through this kind of from ideation all the way to deployment. Now, the problem is not really where they lie, is how they approach it. Sometimes we skip steps. And by skipping steps, that means that we are putting the success of the project really at risk, because we might not be thinking about how to make this thing robust. We're thinking just over the final goal and like, okay, we need to get it out of the door and everybody is going to be happy, but that means that we either make a mistake when we deal with the data and gather biased data. We might be making a mistake and not allowing for, I don't know, enough server kind of like quotas to to satisfy demand. And all these kind of things do come into the TRL kind of scenarios and steps, and by skipping them, it would actually jeopardize the endeavor. It's not, to really answer the question is, companies really are all over the place because they do this every time they have a project, either implicitly or explicitly. The problem is kind of following it rather than skipping steps that we might deem that are not necessary, but at the end of the day, they kind of are.
You mean there's no shortcuts?
No shortcuts, no.
All right, very nice.
Unfortunately.
That's next time. So the question, what do you do if the real world problem is too complex to map out the entire of causality? And the example given there is the NHS is a very complex system. So how do you tackle those big ones?
Indeed, and to be honest, on top of the NHS, for example, you look at climate. Also, the climate is an extremely complex system that you cannot really map out everything. There has been literature about this thing, and it's an extremely interesting point of view, and that you start with small, like you start small, like solving a subsystem, for example, from the point of view of the NHS, a single hospital, or even a single ward, even better, rather than tackling the entirety of the NHS. Or if we're talking from a climatic point of view, we are just gathering data from a specific kind of point rather than all over the place. And then there are ways of changing the level of abstraction. And this is fascinating work that is being done both from a few groups. The first one that comes into mind is actually one from the University of Warwick and some dear collaborators. And they actually do this. They're trying to map when you do an intervention, for example, in a small scale, how in a smaller lower level of abstraction, how that would translate into a different level of abstraction in a larger scale. Fascinating work. I strongly recommend to read up on this.
Thank you. That's good. In your experience, have you seen any intersection between visual ML and causal AI?
Visual ML.
It says visual. Visual machine learning?
Vision, yeah. Actually, yes, there has been. And there has been quite a bit in the medical imaging field. There are some collaborators up in the University of Edinburgh that are heavily investing in it. Same with the Imperial College London. In terms of companies and industry, there's obviously Canon, GE Healthcare, and also a few startups here and there are heavily investing in trying to understand the visual aspect of causality. But we really do that implicitly, really, in a lot of different industries. The fact that, for example, Waymo is able to reason about the things that happen around in the world while the self-driving car goes about the roads is really an element of extracting visual information and mapping it to some form of causal model. Implicit or explicit.
Ask one more question, because then I know it is lunchtime and
yes,
grab you more questions.
I think it's a brilliant presentation right before lunchtime. Doesn't tire anybody and really grows the appetite.
Exactly, exactly. So how did you apply causality to real-time predictions? What was the key value added there?
So that is a very interesting question, and I think Kieran is going to elaborate more on how we do things at Spotify. But the real value added it comes from different levels, because we apply causality in real-time predictions in different levels. There be that, for example, recommendation systems that we might be looking at. So, for example, trying to introduce the notion of incrementality into our recommendation system to have more impactful, really, recommendations. It could be from the analysis point of view and what would us as a company might do or us as individuals might do, and how that would affect, for example, the company, the users, et cetera, the larger ecosystem. But it is, to be honest, from my perspective at least, the value added is immense. Mostly because it gives you a formal kind of framework to think about things rather than putting your finger in the air and trying to figure out where the wind blows from. It really allows us to formalize and also communicate these insights, these ideas better with stakeholders that might not necessarily be as well versed into the technical things as other people. And really, it is so. Again, it doesn't only come into modeling, but actually comes into the people management and into the interactions and the stakeholder management as well.
I'm going to add a big thank you here, because what you don't know is we did have another speaker for this time slot who unfortunately was ill through COVID, so couldn't make it. So Athanasios stood in with just a couple of days' notice.
Yes, so this whole presentation was done at 1 a.m.
Just incredible. So amazing. Thank you so much.